So guys, now we continue that topic maximum and minima, which we have to learn in the previous lecture. So in the previous lecture we learn about maxima, we learn about minima. What is the maxima and what is minima? And after the definition of maxima and minima, we learn about how to evaluate or how to find local maxima and local minima. So here already we learn two examples on the maxima and minima. Here example number 3 is, if a rectangular sheet of paper has its area is 24 square meter. So here a rectangular sheet of paper, if we draw rectangular sheet paper, shape of the sheet paper is rectangular size. If we draw the rectangular sheet paper, so let us consider that it is a rectangular sheet paper. If we draw a rectangular sheet paper has its area is 24 square meter. The area of this rectangular sheet paper is 24 square meter. The margin at the top and the bottom, the margin at the top and the bottom, the margin which is at the top and the bottom is 75 centimeter each. The margin at the top and the bottom is 75 centimeter. 75 centimeter means the margin at the top and the margin at the bottom is 75 centimeter. Both are 75 centimeter. And side 50 centimeter each. Side means both sides, left hand sides and right hand side is 50 centimeter each. If we draw the sides which is 50 centimeter, we can say that the distance between sides is 50 centimeter, which is again 50 centimeters. So here what are the dimension of the paper? So here we have to find the dimension of the paper if the area of the printed space is maximum. So here given that the area of printed space, which is a whole printed space, is a maximum. Area of printed space is maximum. We have to find dimension of the paper when the area of the printed space is maximum. So first we consider that length and breadth of the printed paper. Length and breadth of the rectangular sheet paper. So first we consider if length of the rectangular sheet paper bx and breadth of the rectangular sheet paper by. So here we can write, let x be the length of rectangular sheet paper and y be the breadth of rectangular sheet paper. So here we have to find the dimension when the printed space is maximum. So now we, by the given condition that we know about rectangular sheet paper, area of rectangular sheet paper, area is 24 square meter. So here we can write area of rectangular sheet paper, area of rectangular sheet paper, we consider that A be the area of rectangular sheet paper, A be the area of a rectangular sheet paper and A is equals to 25 square meter. Sorry, 24 square meter. So here A is equals to 24 square meter. We know that the area of rectangular sheet paper A is equals to length into breadth. Here length is x and breadth is y, hence we can write A is equals to x into y, and x into y is equals to 24 square meter. That is, we can write x into y is equals to 24 square meter. So if we have to evaluate the value of y, we can write that is y is equals to 24. The x which was multiple on left side, if we shift this right side, which divided by 24 upon x. So the value of y is 24 upon x. Now after leaving the margin of the sheet paper, the x which is reduced by 50 centimeter plus 50 centimeter means 1 meter. So after leaving margin of sheet paper, length is x minus 1 meter and breadth is y 75 centimeter plus 75 centimeter means 150 centimeter means 1.5 meter. It is breadth is reduced by 1.5 meter. 1.5 meter means y minus 1.5, which is the length and breadth of printed space. So here we can write area of the printed region, which is x minus 1 into y minus 1.5 is already given that 24 square meter area of printed region. So that is, we can write A is equals to x minus 1 into y minus 1.5. So here we can write x minus 1 and the value of y which we have to evaluate 24 upon x minus 1.5. If we multiply this x into minus 1 whole bracket, we can write x into 24 upon x minus 1.5 minus 1 into 24 upon x minus 1.5. So x into 24 by x get cancelled. 24 minus 1.5 into x, 1.5x minus 24 by x minus plus 1.5. If we add this both term, we can write minus 1.5x or 24 plus 1.5, which is 25.5 minus 1.5x minus 24 by x, which is the area of printed region. If we differentiate this area, if we differentiate with respect to x, then we get dA upon dx is equals to derivative of 25.5, which is constant function, is 0, minus derivative of 1.5 into x, 1.5 is constant function, derivative of x is 1, minus 24 is constant and the derivative of 1 by x, which is minus 1 upon x square. Hence we can write dA upon dx is equals to minus 1.5 minus plus 24 upon x square. And we have area of printed space when is maximum. For maximum printed space, dA upon dx is equals to 0. Maximum printed space dA upon dx is 0. That is, we can write the value of dA upon dx is 0 minus 1.5 plus 24 upon x square is equals to also 0. So here we have to find the value of x, which is length of the rectangular sheet. So if we continue this equation, we can find the value of x. So here, if we multiplied x square both sides, we can write minus 1.5 into x square get cancelled, plus 24 is equals to 0. If we shift this 24 right side, it become minus 24 minus plus. Directly we can write 1.5 x square is equals to 24. That is, if we divide 1.5 both sides, we can write x square is equals to 24 upon 1.5, which is 60. That is, the value of x is equals to plus minus 4. Therefore x be a length of rectangular sheet is plus 4, means the value of x is 4. Length is always positive, hence x is not equals to minus 4, only the value of x is 4. If we again differentiate equation 1 with respect to x, then we get derivative of dA upon dx, which is d2a upon dx square. Here the derivative of minus 1.5, which is constant function, is 0, plus 24 into derivative of 1 upon x square, means x raised to the power minus 2. By using the derivative of x raised to the power n, we can say that 24 into minus 2 into x raised to the power minus 2 minus 1, which is minus 3, means 24 into minus 2 minus 48 upon x cube, which is d2a upon dx square. If we put the value of x, which is 4, we can write minus 48 upon 4, means 4 into 1, which is 1 into 2, 12. Therefore, d2a upon dx square, which is minus 12, is less than 0. Hence we can say that the area of printed space, which is x cube, means 4 cube, not a minus 12. Directly we can say that d2a upon dx square is less than 0. Hence we can say that when the value of x is 4, then area of rectangular sheet is maximum. So when the area of rectangular sheet is maximum, then we have to find the dimension of sheet of paper. So if we know the value of x is 4, then we can say that if x is equals to 4, then if we substitute the value of x in the equation, y is equals to, we write the value of y 24 by x, and the value of x is 4, then we can say that 24 upon x means 4, which is 6. So here we can write, therefore area of rectangular sheet is maximum, then length of rectangular sheet x is equals to 4 and breadth of rectangular sheet y is equals to 6 meter. Sorry, here length of rectangular sheet means we can say that length of a rectangular sheet y is equals to 6 meter and breadth of a rectangular sheet x is equals to 4 meter. So the example number 4 is an open box is to be cut out of a square cardboard of side which is 18 centimeter. By cutting the equal square from the corner and turning off the side, find the maximum volume of the box. Here we have to find the maximum volume of the box. So here, by the given condition, we can say that an open box is said to be cut out of square cardboard of side 18 centimeter. So by the given condition, we can say that here the square cardboard, let us consider that it is a square cardboard side which is 18 centimeter. The side of this square cardboard is 18 centimeter. So it says that the side of this square cardboard is 18 centimeter. So here if we draw any square, each side of this square is 18 centimeter. Let us consider that given figure is a square cardboard. By cutting off equal square from the corner, if we fold this square and if we cut the four corners of the square in equal size, so it gives these types of model, cutting all sides, four sides means four corner in equal sides. We can draw on board. If we cut four corners equal side, this gives such a type of figure. After cutting, the corner will be removed. So here we have to find the volume of the box after cutting the corner. So by the given condition, the side of this square card is 18 centimeter. 18 centimeter. If we consider each side of the square which is cutting side bx, then we can say that each side of the square cutting card x plus x 2x, which is 18 minus x. Also it is 18 minus x. Also it is 18 minus x and it is 18 minus x. So we have to find, let side of each side of square small cutting square is x centimeter, then side of box to be made, which is x plus x to x, 18 minus 2x, which is all the 18 minus 2x, which is all 18 minus 2x, to be made 18 minus 2x, and height of the box x centimeter. Let V be the volume of the box, and we know that V is equals to area of base into height. So we know that area of base, which is 18 minus 2x whole bracket square, into height, which is x centimeter. So if we take 2 common from both, we can write 9 minus x whole bracket square, or we can say that into x. Square of 2 is 4 into 9 minus x whole bracket square means square of 9, which is 81 minus 9 into x, 9x, and double of 9x, which is 18x plus x square into x. If you multiply this x whole bracket, we can write 4 into 81x minus 18x plus x cube. So if we differentiate given function with respect to x, then we get dv upon dx is equals to 4 is constant function. We can write 18 constant derivative of x minus 81x minus 18 constant derivative of x into x, which is x square, plus derivative of x cube. So 4 is constant, 81 as it is, minus 18 into derivative of x square, which is 2x plus 3x square. So here 4 is constant, 81 minus 36x plus 3x square, which is a derivative of v with respect to x. So here, if the volume of the box is maximum, then we can say that for maximum volume, we can say that dv upon dx is equals to 0. That is, we can write 4 into, if we take 3 common from these whole 3 terms, we can write 3 into 27 minus 12x plus x square is equals to 0, which is the value of dv upon dx is 0. If we take 4 into 3, 12, 27 minus 12x plus x square, right side, then 12 divided by 0 divided by 12 is 0. We can write 27 minus 12x plus x square is equals to 0. From the above equation, we have to find the value of ax. So again, we can write it x square minus 12x plus 27 is equals to 0. So if we factorize this 27, we get the factor of 27 is 9 into 3. This minus 9 into minus 3 plus 27 minus 9 minus 3 minus 12, we can write it x square minus 9x minus 3x plus 27 is equals to 0. If we take ax common from both terms, we can write here, if we take x common from first two term, we get x in bracket x minus 9. If we take again minus 3 common from next two term, we can write again x minus 9 is equals to 0. Now we take x minus 9 common. We can write x minus 3 into x minus 9 is equals to 0. That is, we can write first bracket x minus 3 is equals to 0 and second bracket x minus 9 is equals to also 0. So x is equals to 3, x is equals to 9. But it is not possible that the value of x is 9. So therefore we can write value of x is equals to 3 and x is not equals to 9. So by using the value of x, which is 3, so value of x is not equals to 9 because the side of 18 minus 2x, if we shift this value x is 9, then we can write 18 minus 2 into 9. 18 minus 18 is equals to 0. It is not possible that side of the any square is 0. Hence the value of x is not equals to 9, only x is equals to 3. So if we differentiate equation 1 with respect to x, then we get dv upon dx is equals to 4 into 81 minus 36x plus 3x square. The derivative of v with respect to x is d2v upon dx square. So we can write derivative of the equation 1 with respect to x is dv upon dx is equals to 4 into 81 minus 36x plus 3x square is d2v upon dx square is equals to 4 into derivative of 81 which is 0 minus 36 into derivative of x which is 1 plus 3 into derivative of x square which is 2x. So we can write 4 into 36 into 1 minus 36 plus 3 into 2, 6x. So minus 4 into 6, we can write 4 into 6, 24x minus 36 into 4 which is 144, that is d2v upon dx square is equals to 24x minus 144. If we put the value of x which is 3 for x is equals to 3, we can see that d2v upon dx square is equals to 24 into 3 minus 144. 24 into 3 is 72 minus 144. We can write minus 72, which is d2v upon dx square is less than 0. If the value of second order derivative, which is d2v upon dx square, is negative, means less than 0, then we can say that volume of the box 18 minus 2x whole bracket square into x. The value of x is which is 3. We can write 18 minus 2 into 3, 6 whole bracket square into 3. 18 minus 6 which is 12 square into 3, 144 into the square of 12 is 144 into 3. And the value of 144 multiplied by 3 is 432 cc, which is a required value of the volume of the box, which is maximum.